Yamin Yasar. This side is excitation, this is inhibition. How excitation occurs? And how inhibition step by step. When an excitatory neurotransmitter is released from here and comes upon the postsynaptic membrane, actually first the presynaptic membrane depolarization occurs. Means sodium go into the cell. Now, see that? It opens the sodium channel. So it's important. It opens the sodium channel. Is it clear or not? So excitatory neurotransmitter like acetylcholine, when it affects, it opens the sodium channels, then localized depolarization, and only here. Then after not only here, but also postsynaptic membrane, the final, this is the final. And the excitatory postsynaptic potential occurs where? In the postsynaptic. Did you get it? Depolarization occurs and sodium goes into the cell and the excitation. Now, how inhibition occurs? For inhibition, either potassium should go out. If they go out, the remaining will be chloride negative. And you know when there are too many negatives, inhibition. In the cell, if too many negative, it is inhibition. If it is too many positive, excitation. So, the other is chloride channel. Chloride will go into the cell. It will also produce more negative ions, and if cell contains more negative ions, means minus 90, it will become minus 100. It will become minus 120. Too much, you cannot stimulate that cell. If the cell is minus 80, you can stimulate it. It is less negative. But if you take the positive ions inside will be more negative, from minus 80 it will go to minus 90. You take more positive ions outside, it will become minus 120. Now, this is the reason, physiology is a ibadah. If you understand memory and learning, you see in the brain anywhere the cells that produce, they are involved in memory and learning, their membrane potential is usually below minus 90, minus 100, minus 110, minus 120. Why? So that in the body, any process could stimulate and produce any action potential. Because they retain memory. If every cell is stimulating and action potential is occurring, how memory will be retained? You understand retained? Yes. How they can keep the memory. So keep the cells that keep the memory, they are too much negative inside. What is the faida? Yeah, you got it. Okay. And the cells that are related to behavior activity, I'm talking, and you are listening, all those, their potential is too, like minus 70 or something. And if that is not minus 70, that is minus 120, you will say something to me and I will not be listening. How I will understand? Subhanallah. So see how everything is in tartil and ahsan tarweem. Very, very appropriate. Like the processes are related to behavior, talking, walking and listening and all doing life activities, their potential is less negative. So that when we do it, we quickly do it. But the cells that store memory and learning, their potential is very negative. Did you understand? Yes. Now any imbalance in this create disease. Learning diseases, memory diseases. Okay. Similarly, the behavioral diseases, like if our activities, some people talk very slowly, not slowly, like even they cannot talk. One word, they cannot talk. They have their potential are different. They should be, the potential should be towards minus 70. Maybe they have minus 120. You understand? So doctor he will diagnose the disorder and he will prescribe the medication, and with the time things become bad. So this is inhibition. Inhibitory post-potential excitatory. Is it clear? I'm sorry I cannot go in details. It's very interesting. We do not have much time. What's the time? We should know it. I keep my cell phone with me. 20 minutes only? Just I want to take Oh, he's hiding. I joke too much. Life is enjoyable. Easy. Okay, so children, yes, we will inshallah. I will also go. Oh, okay. So the next slide is. Did I miss something? You can tell me if I missed any slide. I don't think.
Limited transmission.
Yeah. This is simple, because once the action potential occurs, excitatory or inhibitory, they sum up. Because for performance of activity, you don't need only one action potential, excitatory. No, you need both of it. Summation. What you say in Arabic? Ijtima, jama, jamma. What you say? Muhassar, huh? Okay. So, anyways, difficult. I will, I'll fast this. Okay. Summation, you got it. Summation of excitatory potential or summation of inhibitory. Now, this summation is temporal, as we talked, according to time, zaman, or spatial, according to space. Like time means in first second, second second, third second, 10th second, they all get together. It is according to time. Makan means if this is a place in the brain, maybe this, several places, 10 places. In the same time, same second, but the makan is different. They are summated. You get it or not? Okay, good. And action potential occurs in the postsynaptic excitation of vision. This story is finished, and but the factors that affect the spread. Now see the alkalinity and acidity. If your body acidity, when you go in the lab, they check your pH. You know, usually when you go in the lab, they check your blood. What is pH? pH means the hydrogen concentration, or hydroxyl concentration, hydroxyl. This is very important indicator of the disease. What disease or normality. So if alkalinity is more, you means you are more sensitive, more excitability. Okay, so it means it enhances, increases synaptic transmission. So alkalinity should not be more. It should not be acidity. It should be normal physiological pH level. Too much alkalinity or too much hypoxia, deficiency of oxygen. Okay, or the drugs which there are some drugs that increase transmission. Those are caffeine. Now, if you drink too many times the caffeine, no, your excitation will increase. Don't drink too much. Okay, I think 1 or 2 times, morning, evening, it's enough. If you drink 10 times when you are in stress, usually you do it, and you become more stressful. So your excitation becomes more. So hypoxia, alkalinity, and the drugs like the theophylline and theobromine, but mainly tea and coffee. Tea is better. I usually drink tea. Coffee is too much. I mean, you understand. So they increase synaptic transmission. If you like to keep your level of excitability at certain level, don't use the thing that increase or decrease, any drugs or anything. Okay, number 2, strychnine. This drug inhibits the inhibitory nerve. Inhibits the inhibitory nerve means increase excitation. You got it, mashallah. And drug that decrease the symptoms, like the local anesthetic. You put in dental, one injection, I don't feel I have these, no. So it means it decreases. So make neuronal membrane less. It's the play of sodium channel. Sodium channels are blocked. Local anesthetic blocked. If sodium channel blocked, no depolarization, how we will sense it. So the excitation. I think you got it, how excitation increases. We cannot go in more details. Inshallah, you will study diseases in pathology, inshallah later. This is, I don't think that you have in your notes. Do you have? Well, just I wrote for myself, but if you will say, I can tell you. Normally alkalinity, why alkalinity increases and acidity does not increase. If you say, I can send to leader, but this is not in your notes, okay? So I can send to you for, it's from Guyton problem. You can read Guyton, mostly Guyton, maybe even, but I can send you anytime you need it. Now, what is this? Same thing. Synaptic vesicle, they are broken down. Number 1, how this synaptic transmission occurs. Number 1, action potential depolarizes the axon terminal. Number 2, you got it?
Yes.
Number 2, the depolarization opens the voltage get calcium channels and calcium go into the cell. When calcium go into the cell, what happens? Calcium exocytosis occurs. Means this is the exocyte. Means the components of the acetylcholine come out. Exocytosis. And this is exocytosis substances, acetylcholine come upon the postsynaptic membrane and activity, whether it is neurotransmitter or it is synapse. You know what is the difference between neuromuscular junction, synapse and neuromuscular junction? Neuromuscular junction means nerve combined with muscle, and synapse means nerve combined with nerve, neuron with neuron. So now the last point is reception in combination with the postsynaptic cells with the receptor. I think we have discussed. This is just a beautiful picture. We have already talked about this. Clear? Children, clear? Okay, good. Lecture is not boring, right? Now there is I don't know, it's too much big. I try to go away. Can you read it? Can you see it? If you can see, it's okay, it's good. See that. Temporal sensation, summation and spatial sensation. I don't need to explain it. We already have discussed, okay? This is a picture when you go home. What is temporal? Temporal means according to time. And spatial means according to makan. Okay, so this is clear. And receptor binding. Okay, neurotransmitter and receptor. That is again repetition. When the vesicles are broken down, acetylcholine comes out, or any amino acid, it combines with postsynaptic membrane receptor, right? So this is the story. There are large number of neurotransmitters, like the 50 are the most important chemical transmitters. Acetylcholine, biogenic amine. You can read this. Common neurotransmitters are these, but some are excitatory and other are inhibitory. This is easy. You can read. Any question? I think this is just knowledge. Nothing. There is no idea. Receptor binding, again repetition. Another beautiful picture. But all the things are same. Voltage gain, all the steps are same, repetition. And now neurotransmitters, acetylcholine, repetition. Inotropic receptors. What are the inotropic receptors? You remember? Where ion movement occurs, whether it is voltage gated channel or motion. Nice memory. See, it's like degraded acetylcholine, the glutamate receptors, GABA, all those. Do you have this information?
No.
But just for myself, but you can write. I think it's easy. Inotropic and ligand gated receptors, they form ion channels, and it's called as the. Otherwise, metabotropic are those that has the single transfer mechanism by the cyclic AMP through a second messenger, and this second messenger is cyclic AMP. Okay, I don't put it in your course. I don't know the slides we sent you. This is there? No. Okay, we don't. Okay, but you should know it from other sources. But it's not just for your information. Okay, the metabotropic. This is repetition of. What are the metabotropic? And what is the difference between the inotropic? Because in inotropic, ion movement without the mediation of the second messenger. But in the metabotropic, second messenger is lazim, daruri. See the words I'm using is right. Okay. So these are. I think you can read it. This is also simple. Just the information. There's no idea. Now, Sam, or the continuity. You can read it, please. If you find any difficulty, let me know. Now the neurotransmitter occurs either excitation, for example, glutamate, acetylcholine, excitatory, or inhibition, GABA, gamma-aminobutyric. Sometimes, like acetylcholine, it serves as excitation in the skeletal muscle, inhibition. Simple. So 3 types of the activities. And postsynaptic, yes, this is another topic, interesting topic. Sometimes, this is a very big topic in physiology. The presynaptic, not postsynaptic. Sometimes you can inhibit you means your body, okay? You can even inhibit presynaptic cells, like by producing, bringing out the potassium. I told you, if the more negative ions are there, inhibition will occur. Or if you put you stimulate the chloride channel more, so inhibition. Simple. Now you get that. It's written there. The inhibitory neurotransmitter released by they cause chloride influx. Okay, influx, you understand? Going in. And in the presynaptic site, and decrease in magnitude of action, decrease in calcium influx, decrease in excitation. So it means if you take out the potassium from the presynaptic cell and put the chloride, you stimulate the chloride channel, the negative ions will be huge inside the cell, and we know when the negative cells are more in cell inhibition. Negativity always means inhibition. Positivity always means excitement. Simple. So this is the way of our body do. Our body is very wise, wisdom. Anytime body needs to, why body inhibit the presynaptic cells? Because body does not like to stimulate the person. There's no need of sending message. So what body does? Message is there. Body inhibits the message. This is very interesting. I have many ideas, but inshallah some other time when you will be in 50 years. But this, if you study, you come to me, you need more knowledge, this is my area, research area. Because I'm an electrophysiologist and I do more initially sodium channel later. But nowadays I work at the very molecular interatomic interactions mainly. In the ion channels, how atoms interact and produce changes. And what is the pathophysiology? You know? The science has gone so deep. The two atoms interact, how we study. I give you general knowledge. Just recently scientists discovered a new microscope we don't have here. You know, one was class time is finished? Yes, come please. I thought your teacher is coming. Just, mashallah, in future you will be teacher. Okay. So, very interesting information. You know, the electron microscope, a new microscope has been discovered. You know what they do? They bring two cells nearby, right? Two cells. And between the two cells, microscope is seen. This microscope is called as tunneling. What is it? Tunneling and scanning. Someone got Nobel Prize on this just recently. So there is scanning, tunneling microscope. So between the two cells, there is a atom hanging, not molecule. Molecule is hanging, they stretch it. Now a single atom is hanging and we take the picture of single atom. This is the first time we got the real picture of the atom. But we still do not know orbital ideas, how the electrons are moving. And still, we will need some. But taking the picture by microscopy, I think this is, very interesting. Even electron are moving between two atoms. We see picture, we do not clearly see, but we can interpret these are electrons. So with the scanning, tunneling microscopy, this is my area nowadays, what I'm interested. I started from the epilepsy, the clinical disorder in women. I studied women. With the time I went through tissues, cells, molecules, now very deep and only forces. When you go deep, you study only hydrogen bonding, van der Waals forces, covalent and ionic, but that's it. Only forces. You don't study the structure, only forces. So science is going very deep, inshallah, if you will go abroad, inshallah, if I'm here, we will guide you, okay? And you have just 2-3 years left, inshallah. This is third year, means 2 years. So let me know anytime any student is interested in research, I can suggest you USA, Canada, where you like. You should go. Okay, we don't have that. So this thing is clear or not? Please, why the body do presynaptic? Why? What is the purpose? What is fayda? What is the maqsad? Arabi is coming, Okay, what is the purpose? Why body? Because sometimes message comes and the body is very intellectual. Someone gave the message, but the cell says, no. Okay, keep it. Don't convey. No need of it. Destroys the message. How to destroy the message? Inhibit it. By inhibiting the presynaptic. No, I did a mistake. Did I? Yeah. I left? Yeah, okay. Now this is the left. The integration, sometime one message diverges. One message goes into several cells. 1 becomes 2, 2 becomes 4, 4 becomes 8. And one message goes in 8 places. This is called as divergence. I don't know what in Arabic. Toxin or whatever, I don't know. Divergent, okay. And the other is convergent. Now, 1, 2, 3 forces, they get together and they stimulate collectively. So conversion examples are there. We don't have time, I think we should go quickly. Integration, same idea. You read it, integration means all together. All things go together. You read it, inshallah, this simple, same idea. This is not in your course, okay, in your notes. Is it there? No. Okay. This is serial processing. I mean, one process stimulates the other in series. And if they go parallel, that is the parallel processing. So serial processing and parallel processing. So this is easy. You can also read it. Serial, I think it's easy. This sentence is not there. This is very easy. I think there is nothing. And the summary, I think summary. Today we study. This is same repetition. Today we study the neurotransmission, excitatory and inhibitory, how the information temporally and makan and zaman both wise, and how processing occurs, how integration occurs, what is synapse. All those things relate to neuro